Welcome, we're back with 5 Caillou action here. This one's called Simple Assembler Interpreter. This is the first part of a series. Okay, yeah, we don't care. We want to create a simple interpreter of assembler which will support the following instructions. You've basically got a move instruction, an increment, a decrement, and a jump if not 0. That's the JNZ. And so move will copy this second value into register X, and just note that either a constant value or the content of a register can be copied. So you could say copy the value 5 in there, or you could say, hey, copy whatever's in the variable var1, copy whatever value from that. So it adds a little bit more work. So increment's simple, just go to the register and bump its value by 1. Decrement's the same thing except the other way, go down by 1. Jump if not 0, jumps to an instruction Y steps away, so you can kind of jump ahead 5 instructions or go back 2 or anything. And that happens when X is not 0. So if it is 0, you'll just proceed to the next instruction like you would in general. Programs run that way in general, right? You execute the first instruction, then the next one, then the next one. And so this jumping one might jump, it might not. Register names are alphabetical and they are letters only. Constants are always integers, negative or positive. We talked about the JNZ instruction. Moves relative to itself. For example, an offset of -1 would continue at the previous instruction, while an offset of 2 would skip over the next instruction. Kind of like how we talked about how after you execute an instruction, by default it increments +1 to the next instruction. The function will take an input list with the sequence of the program instructions and will execute them. The program ends when there are no more instructions to execute. Then it returns a dictionary with the contents of the register. So I like to think of this dictionary as the memory. You know what I mean? You could think of it as registers in memory. Also, every command on a register will always be preceded by a move on the register first, so you don't need to worry about uninitialized registers. So that's nice. You don't have to go too crazy with checks there. I'm not telling you not to do that stuff, but there's enough work here to do from coding within a browser where you don't have to go nuts with it. So let's look at the example. So you've got move A5, which means take the value 5, create a variable named A and assign the value 5 to it. Then increment A, so it would go to 6, right? Decrement A would go back to 5. Decrement A would go down to 4. Jump if not 0, A is not 0, right? It was 4, so you go back 1. You decrement it again, it goes down to 3, still not 0. Go back 1, down to 2, down to 1. Finally, it decrements down to 0, and you proceed to the increment. You go up 1, from 0 to 1. And so the output should be 1. Yep, leaving A at 1. And that's sort of what the result looks like. Remember, you're doing a dictionary of string to int, A to 1. I could have used a char, I think, but that's fine. So yeah, there's definitely some work here. Put some, make your own classes, right? Create your own objects. I'm going to take advantage of inheritance. If you want a little hint, you can pause me now if you just want to go into it and think about this all on your own. But for these instructions, right, we've got 4 of them, so I think I'm going to make a general base class instruction and sort of inherit from it, where I can, in that base class, I can sort of place all the common behavior and data to all instructions, and then in each subclass I can override that to get the unique behavior that each command should have. And so I think I can talk my way through this, but let me know in the comments if you'd like me to sketch out class diagrams, if that would be helpful to do these. I don't think it's too bad here, but I imagine as we go higher up in the difficulty, these could become larger and more complex than is easy to talk through. So anyways, without further ado, I'm going to, first, before we write a bunch of code, there we go, Help my OCD, right? You know about that by now if you've been watching me. Okay, good. So I'm going to make a class called program, and that's what I want to think about. I'm going to think about this assembler interpreter, assembly interpreter, being able to create a program from a list of instructions, right? And then sort of run that program. And the program would allocate its own memory, and sort of as I execute the instructions, it gets modified, hopefully in the right way, and I return the memory as the result to this function. So before I even get into it, you know, I like to think about these problems at a high level. Like, wouldn't it be easy, you know, just start, you think of it in layers, very small steps down. Start at a very high level, very low, gradual steps down into more details. So I'm going to make this program class, and it'll look something like this: program equals new program, right? And then what I want to do is I want to say return program run, just run it, right? I did it in a separate step because I'm going to return the result, the memory from it. Instead of saying dictionary string in, I'm just going to call this memory. That's how I like to think about this, as the program memory. Good. So clearly, right, we are going to need a run method in our program class, and we should probably pass in these lists of instructions. And you notice I already conflicted here. I called mine program. This isn't really program. I'm going to rename this to instructions, because that's what it was. That's what we saw. It was a list of instructions that were being provided, a string array holding all of these strings, command strings. And so, yeah, I like that naming better. And so how about if I actually pass the instructions here and leave it to the program to sort of put that in the form that it needs. So good. Then I got to make a constructor, right? You know, it's public program, and we have a string array and some variable name. I'll call it instructions. I like that name. And so what I want to do with the instructions is I want to take each string from that array and sort of create an actual instruction object out of it. And that's going back to what I said about how I'm going to have this instruction base class. I want to actually create objects that are instructions, and we'll flesh that out, so don't worry. I'm also going to need some memory for my program. So let's go private dictionary. They're using string to int, and I'm going to call it memory. Okay, and I suppose I could initialize that here, or you could do it in the constructor if you like as well. Dictionary string to int. Good. And I'm also going to have a private list of instruction. I haven't made this class yet, but we will. I'll call it instructions. And this is that collection. It's going to be just like this, but instead of string, it's going to be something that can actually be executed. That's the idea. Okay, good. So I got those two fields. And so in the constructor then, I'm going to want to do something like string in instructions, right? And let's say I had some handy method that would just load instruction. I'm sorry, I forgot the variable name in here. String instruction in instructions. And I'll load it. Okay, and the idea is that this load method will populate this list that I made here. Okay, so let's say private void, it doesn't need to return anything, load instruction. It's going to take a string instruction as the parameter. And so we've already initialized, we should be good there. So what I want to do then is I have various kinds of instructions, right? There were 4 of them. So, and I want to get the parts of them. So I want to say string array tokens, right? Because remember, this, each one of these strings is going to have two or three parts to it. It could have, 2 or 3. So I'm going to split those up. So instead of all of this, I get 3 strings, one of just the MOV, one of just the A, and possibly a third one. So I'm going to say instruction split by a space, right? It's nothing new there. We've done this before. Okay. And now I'm kind of going to do an ugly if-else thing to see what kind of instruction I have. And that'll be based on the very first string, right? Either move, inc, dec, jump, not 0. Those are the 4, right? So we can say if, lost my cursor. If tokens 0, right? That'd be the first one, equals move, right? Then what we want to do is add a move instruction. So we'd say instructions, add, we know that's the method to add. And then we would say new move, and then potentially some arguments to make a move instruction. This will be a class that I make that inherits from the base class instruction. I'll fill that in, don't worry. And then you can imagine the rest of them, right? It's something very similar to this, like didn't mean to do that. Else if increment, add an increment. We've got 4 of these, right? So we'll do a dec and a J and Z, right? And if you don't like how I'm using magic strings here, you can create some variables for those. I figured we have enough work to do here. So let's do one safety thing. Else, meaning it's some command that isn't valid. I'll just keep and give yourself some message. Invalid command found tokens 0, right? That shouldn't come up. They told us they wouldn't do that. But just in case. So yeah, we're finding the type. Let's see, I made increment. This one should be decrement. Let's call this one jump, not 0. Okay. So yeah, that's basically the idea. So you can imagine this list of instructions. When this is done, we'll have, any number of these, some list of instructions, and that represents what your program should do. It should start at index 0 and execute them one at a time, possibly jumping around if it hits one of these jump commands, right? But if not, then it progresses forward one at a time. Good. So we have our instructions loaded up. I think that's good. And let's get into, let's see, what should we do? Let's get into, I'll go ahead and start that run method that we promised up above. Remember I said there's going to be this program run. So obviously that's going to have to be a public method, right? Public, we're going to return the memory. I just tried to keep this concise. You could have made the memory publicly accessible if you wanted. And we'll call it run, right? So the idea will be then that we've got this here next. I'm going to call next for the next instruction to execute, right? And then you got something like while next is less than instructions.count, right? Meaning there are more instructions to run. You can say next plus equals instructions next, starting at 0, then maybe 1 or jumping around, and then execute. So each of my instructions in that base class are going to have this method execute. It doesn't matter what kind they are, right? They all need to be executed. So I will provide that. And then you'll notice how I'm adding the result. So what I'm going to do with this method is return how much to increment the program counter by. Usually it'll be 1, right? For move, increment, or decrement, I'll just say return 1, meaning add 1 to next. So if you were add 0, you go to 1 next, and then 2, and then 3, you know, because you just want to step through if there's no jumping. But if you have a jump, this could be a negative value, could be a positive value, and it will move next to where it needs to be. And as long as they don't give us any jump commands with ridiculous jump values that go outside the bounds of the instructions array, we're fine. They said they weren't going to do that. I've got enough coding to do here where I'm not going to worry about it, but feel free to protect against that if you'd like. And then the idea being is that when we're done with this, we can simply return the memory, because that's ultimately what they wanted, was those register values at the end. So yeah, memory was of this type. So when I call program run, that should satisfy the whole challenge, right? That's what they needed us to do. But we're not there yet. We're just, you know, we're filling this in. We're off to a good start here, but now enough glazing over this instruction thing, right? I think we're good here in the program class. Program has memory, has instructions, right? And you can run it. You can create other programs with other sets of instructions. So I like this. This is good. Okay, let's get into another class. Let's do this instruction base class, right? And so when I thought about it, in instruction itself, this base class, it's too general to be useful, right? There's nothing I can say to actually execute based on instruction, not knowing which type it is, right? But it's not entirely useless. We can say it's going to have operands, you know, it's going to need to access memory. So those things, it's going to need an execute method, right? Because this is sort of the beauty of inheritance in polymorphism, is that, where was I in run? This bit right here, right? Remember, instructions holds all the different types, but they all have execute. It's like, I don't care what kind they are, I just need stuff that has an execute function. And it works out. It keeps things really simple here. I don't need to do any kind of looking at what type it is. Don't care. Give me, execute it, move on, give me the results, right? So that's good. I like that. But we're going to have to add this. And so anyways, my point with the instruction base class is that it's too general to be useful, so I'm going to make it abstract. Meaning you can't actually instantiate this class. It wouldn't make sense to do that. You can't use it as is. You have to subclass it and give it some definitive concrete behavior. So that's why I did it that way. So we will make a constructor for our class. Public instruction. Right, and what are these things going to need? Well, they're going to need operands, right? They need data to work on, you know, either constant values or register names, something like that. So I will use that as a list of strings. That's how that was provided to us, right, in strings. And I'll call it operands. And then I want a reference to our program memory so I can modify it. And I want all the instructions in my program to be pointing at the same memory. I don't want all different memories, because that'll not give me the right results, right? These things need to be interacting with each other in the same registers, not two different A registers, you know, in two different universes, right? So I'm going to add a memory reference here, which they're using as a string to int dictionary. I'll call it memory. And those two things, I think, are enough for us. And basically, all I'm going to do is create a couple fields here to sort of store these values, right? So I'm going to make them protected because I have the intention of subclassing this class. So I'll say protected. If you haven't seen protected, it's just another one like public and private, but it's sort of like private, but subclasses can access it. It's kind of like giving a pass to a subclass. So protected list of string, I'll call it operands. And we can say anyone can get it. We're the only ones who can set it. Good. We'll do the same thing for memory. We can say protected for the same reasons. Dictionary, string to int. We're calling it memory. I'm going to say get private set. Good. And then clearly once we have that, we can say in the constructor operands equals operands, and uppercase M memory equals memory. So we're just grabbing, when you create the instruction, we're just grabbing this data and storing it, and it will be available to our downstream subclasses. Good, but I did promise that this was going to have an execute method, right? So we'll say public abstract int, oops, execute. Okay. And remember, I'm returning an int because that's going to be where to jump next for your instructions. 3 of them are just going to automatically do 1 because normally I want to go up +1 to the next instruction. So that's why I'm returning an int here. I'm just kind of combining things. You don't have to do it that way, but I thought this made things a little more concise, and I like it. So again, it's abstract, so I don't have to provide a body to it, right? I'm just kind of putting a signature here. Abstract meaning, what would you even do here, right? Think about it. What can you execute? You don't know what kind of command it is or anything. But when we get downstream to the subclasses, we'll put the exact behavior that each command should do. So I think that's enough for our base class there, the abstract one. Let's go ahead and start filling in the instruction subclasses. So I can say class move inherits from, remember you got this colon, instruction. And so when I do that, it's saying, hey, move. Right out of the gates, I get everything that instruction has. All this stuff I just typed up here. It gets all that. And then anything else I want to sprinkle on top that's relevant to a move command. And you can call this move command if you want. Maybe that's not the best name, but I think you know what I mean. And so public move, and it's going to have the same arguments as the base constructor. I don't need to add anything else. This is all the data I need to work with. All right. Okay, good. And then basically what I want to do is just pass this data along to the base class. And I don't have to do anything else. That's enough. That gives me everything I need. It makes those fields have the values from the commands. Good. Okay, so now we got to do our execute method. And execute. Okay, so let's think about what it means now. Now we can do something concrete. We know what move means. It means to get a value and to move it into our memory, or grab the value at an existing memory location and put it in another memory location. So the first argument is the register that we're dealing with, right? Remember that. So I'll say string register, sorry, don't capitalize local variable names. String register equals operands 0. Now, when I passed in I didn't do that yet, but we won't add the command name here. I don't need it. The command name doesn't help me. I already know I'm in the move class. So you can think of operand 0 now as actually being the second value. We're just basically going to drop the command name because I don't have anything to do with it. If you wanted to make a type field and, populate it so maybe that helped you in some way, you could look at an instruction and see what type it is. I don't need that, so I'm not going to do it. And then we can grab the operand, call it operand 2, or how about let's see, it wouldn't be a value. It could be a value. I'll just call it operand 2. That's fine. And I'll say operands 1. That'd be the second value. It'd be the 5 here, right? And I didn't make a first operand, so I'll just call it operand. Good. Okay, and then so remember, it could either be a constant value, a number, or it could be a letter representing a memory location. So I'm going to check, going to make this int variable, and I'm going to try to test operand to see if it is in fact an integer value, and if not, it refers to a memory location, right? And then I'm going to use try parse to sort of find that out. Int 32 try parse, and we'll pass in the operand, and then as an out val for value. Okay, and if that is successful, we could think of it as being an integer, so maybe it's more expressive if I said is constant or is number, meaning it's not a variable name, however you want to name that. So if is constant, right, we can we want to check that the memory contains the register. That'd be a good thing to do before we assign it. If, remember, we have a memory field that came to us from the instruction base class, right? If memory, remember dictionary contains key register, right? It should, and then we can assign to it. We can say memory register equals val, right? And then otherwise, memory that if it's not in memory yet, which I guess will usually be the case, usually if they're using move, it's when they start a new one, memory add, and then we'll say the register and the value. Good. So if it's already there, we're going to update its value with the constant number, else make a new entry in memory with the register name and the val. Good. So otherwise, right, meaning else would mean it was a string. There was not a number in there, which means, okay, this is another memory location. So we're basically going to do the same kind of thing, right? In fact, I'll kind of copy this, and you could say if memory contains key operand, that was what we found, then we would set the register value to the memory, to the operand, right? We're assigning, we're writing over the register with the other register's value, right? They told us it could happen that way too. And then if operand 2 is not in memory, we'll just throw an exception. There's nothing to copy from, so we should never get here. Throw a new exception and something meaningful, move, execute, no register by name. That was operand that we were trying to copy from. Okay, good. So we got all that, and then if you remember, our return type's an integer for, let me blow this up a bit so I can see where this ends. There's where the method ends. So yeah, in this case, I'm just going to return 1 unconditionally for these first few instructions. They don't do any jumping. There's no chance of jumping, so I'm just saying, hey, go 1 instruction forward. That's all I meant by that. Good. So that should cover move. Let's go on to do increment. We can say, oops, let me make sure I'm starting a new class. Class increment, and keep in mind when you're in your IDE, this is going to be way smoother than trying to type this all into a browser window. So that could be another issue where we run into a practical limit, but I'm going to do my best to code right from the browser here. But you would make all new files for all these classes. They'd be tiny classes. You could see them all on screen. It's great. But we're working with what we have, right? So same kind of thing. We're going to have a constructor. It's going to take the same arguments as the other. It doesn't need anything special. In fact, I'm going to copy that whole bit. Right? You don't need anything extra for the increment. We'll just say, hey, go to the base class and store that data for us. And then we need our execute method. So what does it mean to do a increment? So this one should be a little easier. We'll say string register equals operands 0, just like before, right? And then it should be followed by a value. Or I'm sorry, not a value. Increment just takes 1 because the value is 1, right? You're adding 1 to it. So simple enough. Let's make sure this register is contained. If memory contains register, if it does, then we can simply increment its value. Memory register, you can increment it. And otherwise, you got a problem. You can't increment something that doesn't exist. And I'll just copy something like that. No register by name register. And so we got that, and as you can imagine, again, there's no possibility of jumping here, so we're just going to return 1 to signal to go to the next instruction. You can imagine decrement is almost exactly the same. So let's copy that, rename it, execute, and then instead of plus plus, of course, you would go minus minus. And we should make sure our error message will help us and not confuse us. Looks good. Okay, and then the last one would be jump not 0. Or you can call it jump if not 0 if you want. Or anything. I'm not the boss of you, right? Okay, jump not 0. The constructor will be the same. We need that information. Nothing new there. Explain that. Okay. And then we need our execute method, right? Because if you don't implement that method that's needed, you get in trouble and you get yelled at. That's good. I want to be yelled at. I want to know if one of my instructions can't be executed. Okay, good. So jump if not 0. And I think this had a bit too where it was can refer to register names or constant values for the check against 0. So we can start by grabbing the register name. Equals operands 0. Okay, and then we will do the same kind of thing. We'll check if the register is an integer value or a string value. And I can say int val, and then I can say bool is constant, meaning not it's a number, not a register name, equals int32, try parse, and we'll do register out val, meaning try parse will populate this value for us if it's successful. Good. And so we'll check and respond appropriately if, oops, constant, if it's not a constant, meaning it's a memory location. So we should say if memory contains key register. We want to make sure it's there, right? Because it was not a numerical value, it was in fact a register name. Then we can say the val equals memory at register, right? We're just making sure it exists, so we're not accessing a bum value. And then, yeah, A could have 5, it could have 7, maybe it has 0, and that's the value we'll compare against. So otherwise, we have a problem if we're trying to access a register that doesn't exist. I'm not gonna get too much into the exception handling. Just say no register found register. Anything you want. It's not the focus here. Okay, good. So otherwise, we handled the case where it is a register name, but we have the case where it is a numerical value. And so actually I can use I don't need to cover this. Let's add one more thing too and get our jump value, which was the third part of that command. Remember, you had JNZ, you had a register name or a numerical value, and then you had the amount to jump, right? How many instructions ahead or forward to do, and that would be the last operand. And it should always be a number. That was the only possibility for that one. In 32, parse operands 1. Good, so we got a jump. That's our jump instruction. Okay, good. And so what we can do now is we have our val. So we can say return val equal to 0. If it is, return 1, meaning go to the next instruction. Otherwise, return that jump value, right? Good. So we've made classes for all the instruction types. Let me make sure I created those because I think I glossed over this with load instruction. Yeah, good. So remember now, for each of these, we just said we were going to share the memory, which will be this, and the rest of the instructions. We don't need the first one, token 0, so I'll take everything after token 0. And to do that, I can use skip, right? Remember skip? So we can say tokens skip 1. That'll just skip over token 0, right? Good. And then also provide the memory to work with, and we want all the same memory. And this will be the argument to all of these. Good. So let me see if I think this is worth a shot here to try to run to see if I'm sure I typed something wrong and maybe you've been yelling at me like in other videos. Let's just test it, try to fix compiler errors and all. Okay, line 77, I missed a semicolon. Let's get down to 75. Oh, I'm sorry, 77. Yep, sure did. Good catch there, buddy. Okay, error on 123, dictionary string int does not contain a definition for contains. That's true. Should have been contains key, probably. Let's go down there. Memory contains key, right? It's fair. Oh, I did it a bunch, didn't I? Sure did. Contains key. Sometimes I just run the test to spit the first error off so I can see the others. Line 42, argument 1 cannot convert from enumerable string to generic list string. Okay, let's see what I did on 42. 42, what did I do? That's a list of string, list of instructions. Skip. Oh, I see what I did. Remember, skip from link returns an enumerable, right? And we called these tokens as a list in the constructors below, right? So remember, in our classes we called it a list of string. So instead of an enumerable of string, I'll just convert those to lists. Let's do to list. Good. Good. Copy. Copy. Try again. Okay, green. Good. But I'll hit the bigger one. Okay, cool. I'm clear to submit. I'll go over take one more pass over this just to be clear what I did. I created this new structure called a program I made it so it was really easy for me to work with, right? Like if I'm the guy who has to work with the program class, look at this. All I have to do is create an instance of it and hit run and my program runs. That's nice, right? Like the guy who made this class is looking out for his clients, right? Or her clients. They're making it easy. That's how it should be. You notice how I put the public stuff first too? Because that's what I want people to be able to see first. Those are the things that they're able to use. They're not able to access the private stuff. I want them to see it up front, what they have to work with when they use my classes. And so, yeah, I started at a very high level here and I just tried to flesh it out a little at a time. You know, a program is this thing that has memory and a list of instructions, and then it just sort of, when you run it, it starts at the beginning and it sort of steps through instructions one by one unless you tell it to jump. And so the instructions, I made it handy by having their execute method return the jump amount for the next instruction. Usually 1, but possibly jumping around forward or backward somewhere else. And that made it really easy to cycle through this until you get to the end of the program. And then what they said they wanted was the registers, so I gave them the memory. Yeah, not much. Load instruction. We just went through that string array that the problem gave us and created this list of instructions that we executed in order. And the list structure was nice because it allows you to index anywhere you want. And so I have this next variable that sort of is like the instruction pointer, right? It's pointing at the next instruction. I can bounce that all over the place. And that's good for a list. So yeah, and then we had this abstract class instruction, right? That was handy because it gave us all these things that all of our other classes get by default. They don't have to each copy all this code all over again in all the subclasses. Imagine we had 100 instructions, you know, in a more realistic scenario, or many more than that. Can you imagine copying all this code around that many times? And so, and then we set up the execute method because you can almost think of it like an interface too. We're saying we want all instructions to be able to be executed. And so we're sort of guaranteeing that this will be there and we can use it and not have to care about anything else. Let each instruction worry about the details of how it works. And then, yeah, we did our subclassing with the colon here from instruction. You could think of it, they use the language move, quote unquote, is a instruction. You know, it's kind of the relationship there. and then we went through and we took our operands. In some cases, we had to check if they were numerical values or if they were references to memory registers, and we had to act accordingly based on whether they were numbers or memory registers. Most of the time for these simple instructions, we just returned 1 to go to the next one, but in the more sophisticated or complicated jump not 0, we had this possibility of a jump. If the value was 0, we could say, hey, just proceed like all the other instructions. Otherwise, you need to jump by the value that was passed in as the operand. So I hope that's clear. Again, let me know if you would like me to sketch out class diagrams to make this easier to follow. I'm hoping my language did it, but I don't mind. I want to give you the best experience, make things clear for you. I'll go ahead, and I don't think I have any comments really to get rid of. So I'll go ahead and submit mine like this. Yeah, that works for me. Got those kata points there, honor points. And yeah, if you want, see what other people did, you know. That's a very nice compact solution there. But yeah, see what else you can learn. Otherwise, yeah, give me that feedback on some of those questions I asked. Let me know what cool ideas you came up with to solve this one. And we'll keep trucking otherwise. Thanks for watching as usual.